I'm supposed to be sleeping right now. My body is, but I'm here. All right, cool. We're going to talk about production-level Docker. I'm going to make an assumption that you are already somewhat Docker aware. If you are not, I'm here all day today, and just catch me somewhere. We'll have a conversation. I'm happy to have that conversation. For me, I have been working with Docker since version, it was pre-0.5, so 2013 is when it came out. I was asked to be part of a research development group working on cloud solutions, and they're like, what's the future of the cloud? Like, we're, as humans, reliably good at predicting the future, which is ridiculous. But as part of that effort, there were three things that we thought were life-changing, game changers, if you will, in the cloud space, and Docker was one of them. And it's kind of fun to know that that's come true, right? I'm also an Apache committer on a couple of projects. I work for Mesos, where we focus on putting Docker into production. At one point, in fact, it was really the only production-level option, but we're going to talk about a number of different things that are true today. So Docker. We got this interesting situation, right, where where did this come from? How did we get here? Docker seems to kind of capture the hearts and minds of developers who have been focused in particular on the DevOps space. They're like, this is it. In fact, we could write once and run anywhere. Have you heard that before? Well, we could do that for more than than Java, you know. And in the truest sense, like we could write once and run anywhere that you have a JRE, right? That'd be the truth of it. And that's also true with Docker. We could write once more than Java and run it anywhere where Docker runs. And where is that? What does that mean? Well, really, so far in the real world, in production, it means Linux, period. Right? Like, there's efforts to drive that further, and we could talk about that if you'd like at some point. But that is the real world today. So Docker's written in Go. I don't know if that's important. I think this slide actually articulates a number of things. Capture, if you're new to the space, captures really the core of what this container thing is. We have this need to deploy things into a production, or actually in a compute environment. And typically, we have a VM. I wonder, in fact, if we would have called it a container at one point, right? It contains things. And then what we really mean by container oftentimes is it isolates things. But in the effort of isolating things, it requires a guest OS. So we have a bunch of resources that are required in order to host this environment and provide this isolation that we love. Challenge there, of course, is that consumes resources. The statistics are roughly somewhere between 7 and 15% of your data center is consumed by virtualization. I usually just like to use a round number. Let's just say it's 10%. So 10% of whatever your data center is handling things like the guest OS resource needs, the hypervisor, and things of that nature. Also, it tends to be that VM takes minutes, oftentimes, to come up, and that's just the operating system. That's not even the service. So the amount of time it takes to come up and run is challenging. On the far side, we see this more of a container situation as we know it today. And I'd like to break this down like into the basics, like the low level. And the low level elements of Docker or any containerizer is really just C groups and namespaces. That's it. C groups provide the restrictions that we like. Namespaces provide the kind of the view of the world from the processor's from the process's standpoint, or the task inside of the container. It really is that simple. And we've had namespaces and C groups in the Linux space for a very, very long time. And all containers are, or Docker is a way of, let me stop for a second. It's more than that a little bit, but the core of the runtime is really just namespaces and C groups. Docker actually did something really cool and interesting, and that's they threw on this file format that will become important to our conversation in the next 30, 40 minutes. All right. So, and as developers, this was the excitement, right? We could just spin up an instance of something. No longer need to read a multi-page wiki on how to stand up Couchbase or whatever, or Redis. You just say run, and this was exciting. Now, this makes great demos, and I'm sure over the last few years you've seen and been impressed, as I have, on how easy and exciting it is to spin up a Docker instance. But that's just not the real world when we talk about production. So we have this fight, right? This incongruence, this challenge. As we move into the production area, we like the idea that we could use the same thing in dev, stage, and production, or QA, whatever you want to call it. But as we start to move out, there's different needs and concerns that oftentimes as developers we're not evangelizing. That might be a good word for it. So we have this contention, right? Sometimes, I'm going to make another assumption. I'm going to make the assumption that most of you are dev in here. So if you're not, just enjoy the trip. But, and you know, as a developer, trying to understand the ops needs is kind of like an American trying to understand Polish, right? Ale trochę rozumiem po polsku. So, right? All right. So we have this need, this drive. We have a term that's going to fix it all, right? In fact, this term, DevOps, it's going to make software engineering great again. Welcome to America. All right. So maybe politically charged. I just want to get you to enjoy the trip for a bit. So after dev, what is that? What do we do here? How do we land this in production? Well, the traditional way, in fact, one of the early ways that we took a Docker instance and spun it up is, here's the detail, right? Here's the part that matter. As dev, we are the evangelists for change. We drive change. Completely opposite than ops. What does ops want? They want predictability. They want it always to be the same. They never want it to change, and they know their tool set. In other words, in ops, if we increase beyond the memory constraints that we define for the process, we want it to die. That seems like a strange thing, that we would kill things that we want running. But that's the predictability that we want. So there's this whole push in the ops space of maintaining the status quo, if you will, the known environments that have been tested and verified and work. So the traditional way was to have this legacy data center, or I call it legacy thinking, really, where we just stand up instances. We have physical devices, which we slice and dice into virtual devices, and we statically partition. And by that, we mean we take those 9 things and we say, that is Tomcat 1, and that's Tomcat 2. And all of a sudden, we create pets. And by pets, I mean we have named things that I take care of. You know you're in this environment where you're like, this is Hadoop 1. I'm going to take care of it. It's my baby. And if it goes down, I'm going to go fix it. In other words, you care. And this is the model that's still prevalent in most data centers, and it's super challenging. This is not what the high-scale operations teams do. If you go to Facebook and LinkedIn and Netflix, in their world, your only option is to never care. We call it like treating it like cattle. It's just another node. It's either there or it's not. If it's not there, we'll replace it. I don't care. Here's how you can decide or figure out in your own data center whether you are in this legacy space or not. If you are using Chef or Puppet and you have thousands of recipes, that means every node is a snowflake, and you're in a legacy space. Because in this space, if you move more into a dynamic space and you treat things like cattle, you probably have a handful of recipes, just because they're all the same. Now, there's variations and differences, of course, and we could get into that if you like. But all right, so we want to move out of this space. In the early days of Docker, going into production, what they would do is they would literally just have a script, have a Docker process, spin it up. But this is not a very mature space, and so I want to talk about this kind of maturity model of moving Docker into production and what the consequences might be. In the world of spinning up an instance of Docker and just running it in production with your Chef, Puppet, Ansible, Salt, whatever you're using for provisioning, you run into all the consequences that were prevalent here, along with wasted resources, lack of elasticity, and you're trading things like patent. And what it really means, what it boils down to at the end of the day, it costs you more money because it costs you more ops time. It requires humans. This environment requires humans. It's optimized for humans. And I could go into what that means if you like. So another option, one that Docker would popularize, is compose. Fig became compose. All of a sudden, we have some way of describing one container has a relationship to another container, and I don't buy into it at all. This is fantastic when you're in dev. It is fantastic when you're in QA. There's some really great stuff. But to think that you're going to take a static model of a relationship of multiple containers and then spin that in production, But just think about the consequences, the negative consequences of this situation. What happens when I have a front end and a back end and I need more scale on the front end? Do I just spin up another instance of all the things? Is that how you run your operations? How do I scale up my back end without my front end? It's a model that's somewhat static in nature. It's convenient, it's nice, but it's not a production option, at least for me. So what it means going into production is you're going to pick one of these orchestration tools, which I will go into a little bit more detail as we move forward. You're going to move into either the Mesos space, and Mesos has a number of frameworks out there, toolkits around it. I work for Mesosphere, where we've built out DCOS, or the Data Center Operating System. And I could go into heavy detail on that. I've been working on it for 4 years, so it's something that I'm happy about. And it's somewhat different. I can talk about those differences too. But on the Mesos space, just talking Mesos in general, you've got Netflix created a whole open source project. They re-platform everything that they had, moving from a Java, Amazon-centric world to, they're still using Java, but they have abstracted themselves from the cloud provider, which is very, very healthy for them. So they've moved into the Mesos space. Twitter completely runs on Mesos as well. Now, at this level of scale, we're talking, for some reason, I'm not allowed to give the exact numbers. I've never really asked somebody why I can't, but they just tell me not to. But I can say that at Twitter, they're running tens of thousands of nodes and closely approaching 6 digits instead of 5. So that's a lot of nodes, a lot of scale. In fact, oftentimes they will come into work, and if they look at their metrics board, if something comes up and then it dies, you see a meter that looks like this. We call it flapping. They'll have hundreds of nodes flapping, and at some point they're like, yeah, we should probably go fix that. Like, that's the amount of resources they have, right? So that's probably not all environments. Let's see here. Mesos been around for a while, actually, a little bit longer, in fact, than Kubernetes. But along came Kubernetes at some point as Google's solution has now been adopted by a number of organizations, has pretty much become, like, you can't ignore it. It's the de facto standard to a certain extent. There are some consequences to that as well, which we will walk through some of them as we talk. I've added in here Swarm. Now, Swarm has been rewritten like probably 3 or 4 times, and it is the latest incarnation of it is relatively kind of a lightweight Kubernetes, and it looks somewhat cool. I have never been in a position where I've felt like that would be a reasonable recommendation for production yet. If you're going to be in production, I'd be going in with Kubernetes. Now, the challenges, of course, that you have, Kubernetes, DCOS, there's a lot of complexity to it. That's usually the heartache, is the complexity. I would also say on the DCOS side, there's more configuration possibilities. It's less opinionated, which requires more configuration, and sometimes people have a struggle with that. But it has more options. There's a number of positives to it, but the consequence of trying to roll it out yourself. One of the big negatives with DCOS or Mesos, how do I develop on my local machine? I just want to develop on my local machine to deploy some things. Devs really struggle with that. On the Kubernetes side, really awesome. I'm going to get Minikube out, start playing around with it as a dev. I can do some amazing things. Really hard on ops to actually install it. If you've ever looked at installing Kubernetes the hard way, you'll get it. A lot of it has to do with the connectivity at the underlying layer, things we don't, as devs, care too much about, but connecting and the networking and managing that within the Kubernetes space. Now, as things evolve, of course, things are identified as the hard stuff, and we work them down, and we work them down until we improve things. Things are improving in all these spaces. All right. So after dev, the things you didn't care about in dev, things that matter, networking, the size, builds. Okay, we're going to talk about a few of those things. Kind of the latency, if you will, of standing this up. So we're going to move into a space where, let me pause for a second. Remember we talked about, ops, they wanted to maintain everything. They don't want any changes. What they ran into as soon as you start pushing Docker into the production space, they're like, wait a minute. I used to be responsible for this. I was the one who provisioned a node with Java. And you're telling me now you're going to give me a package that includes that dependency. And they're going to have all kinds of concerns like, well, what happens when Java has a security issue and I want to patch it? How do I manage that? There's all kinds of concerns as we start to move into this space that if this is new to your organization, your ops team's just going to be scared. I will also add that at Airbnb, they have two, and I'm talking years back now, I've lost track of them, but years ago, they had two clusters. One was their microservice-based architecture, the other was their analytics, back-end services. They were separate. On the microservice-based architecture, I'm not sure what that was based on. I can tell you it wasn't Mesos. Their back-end architecture, Mesos. Same size clusters, of course, different needs to a certain extent. Same size clusters. They needed 8 ops to run their microservice-based architecture. They had less than a half to run their the Mesos architecture. There's a serious threat of the reducing of the needs of ops once you move into this space, which can be threatening. So it's just, that's political, I get it, but it's the real world. So, this was supposed to build out, but we'll just work with it. Okay, so production Docker, what are we concerned with? Well, we want to reduce the latency of an image pool. We'll talk about a couple of techniques at how to manage that. It's not your first concern, really, but it is a concern eventually as you start to mature your environment. So we get into image management, which drives some of that. We'll get into some configuration management. You might have some intellectual property. Do you want to put that on Docker Hub? Do you want to have it in your own private repo? Do you want to have a private, can't think of the right term now. I lost my train of thought. Repository at Docker that is essentially secured by passwords or credentials. There's a couple of different ways you might want to manage that. As you start to drive down this path, there's also new concerns. Well, if this is not going to land on a well-known node, how do I even debug that? What's the master way we debug things in production? Anybody want to take a stab? I'll get some. How do we debug things in production? Logs, yeah, logs. It's all about logs, right? So I got to figure out what those logs are. I got to be able to read them. This is the challenge, right? Now, again, in the more advanced space, you still need logs, but you move out to using some, maybe some tracing and some metrics and things like that that provide additional benefits there. Let's look at the Docker image. So first, notice that when I do a Docker pull, there's a SHA, there's a SHA, there's a SHA. What we have in this space is a tarball that is identified by a SHA that is stacked on another one with a dependency order. This becomes extremely valuable in our understanding of this. When you have a line that's defined, I'll show you in a slide in a few minutes, for a Dockerfile, that line will create a new SHA. That's your point. What that identifies for us as we move in a more mature space is a couple of things. First, I would start with a small image. That's their starting point. What's the small image? Most people are using Alpine. There's some concerns, hey, this is a new operating system. I can't just do apt-get install on Alpine. I do it APK or something along these lines. So it's a different environment. If that throws you off, use Ubuntu, use Debian, use whatever you want to use. There's some advantages in making this a little bit tighter as you advance in your understanding. The other point here is that these SHA stack on each other. If I base multiple images, multiple Docker images, on the same Docker base, when I do a pull, it's already cached there. So when I go into 1,000 nodes, and I land on a node, and I do a Docker pull, and it's the 10th image that I pulled, but that particular image has never been on that machine. When I query Hub for the image, it will go, you need all these SHAs. At the client, it'll say, I have all of them, but the last one, can you send me the last one? All of a sudden, it changes my latencies a lot, right? So that's what we're going after. Was that too abstract? Is everybody, any questions on that? So we're going to go out to Docker Hub or a repository. One other part of advancement, you're probably going to use a proxy or maybe an internal to the data center registry to reduce the latency of going off-prem or off-cloud. Okay, so we're going to make this call, and it's going to be cached for us at a proxy. It's going to land on our node. When we're looking at our Dockerfile, the most important thing here, I think I've already communicated. Oh, you know what? Let me start over. When you're first starting out and you're developing, super awesome playground. It's almost like a REPL. I'm going in there, I'm running, I'm installing this, I'm running that. It's awesome. It's great. That is never the image that goes in production, right? Is everybody cool with that? It's like going into your Java REPL and deciding, yeah, just make that bytecode and let's run that, right? That's just not the thing you're after. So at the end of the day, we need proper versioning. We need version management. It comes out of the Dockerfile. What's super important, again, is this: where are you coming from? You want a nice base. As I mentioned before, each one of these lines is essentially another SHA or another layer of tarballs that will land for you. You'll see a couple of things here, apt-get, update, and. These could have been separate lines. Why are they not? We can collapse, flatten, squash, whatever the right word is, the tarballs by using the and key here. So that's where you start to see more advanced, almost unreadable, I shouldn't say it that way, but they're more challenging to read for sure. And you're like, why did they do this? It's usually to reduce the SHA count so that I have a little bit more control over that. All right? So that's our Dockerfile. Versions. All right. It's going to get controversial, I know. First of all, always, when in production, it's always version. There is no such thing as latest in production, right? Never. It's always the version of a thing. It also means that when you're back here, it's always a version of a thing. If you want to break your environment, and what I mean by that is have inconsistent experience across the cluster, use latest anywhere in your chain. It'll cause you headaches and problems, all right? So super important. You're going to version your deployments, and that version will be tied to a version of Docker. If you're new to this space, we often will see shorthands. It's super convenient as a developer. Docker, run, Nginx. Great. You know what? It's not the full namespace. The full namespace is Nginx, up here 1.16-0 Alpine, all right, which is super small and super awesome. All right, so versions. Never snapshots, never latest. Based on doing this and knowing that you went for a specific version, you should never need to configure for a force pull. This is somewhat debatable again, I guess, not to me. But oftentimes people will do a force pull, which requires essentially a Docker pull of the images, regardless of whether it's cached on the local machine or not. That is absolutely not necessary if all images are immutable. If the cache is immutable, if there can never be a change in the version of the thing that I'm running, then you should never, ever need to do a force pull. All right, that's more on the advanced side of things if you need to do something like that. And I would challenge your whole configuration management at that point if that's ever necessary. All right. Small. Focused a little bit on small. Again, I would choose to be larger for the convenience of my environment. If I got heavy Debian users, I might choose that as a consequence, knowing that I'm going to have that, essentially that image or that tarball basically across my whole ecosystem. The latency will go to almost nothing. It'll just be based on the deltas of the things that you're running. That said, there are some things you might consider. It's still nice to pop into a container and have Vim. It's still nice to have tail or curl. Figure out what your debugging or dev tools might be, and probably include that in your base image of what you're using for all your projects. Does that make sense? Super, like not necessarily what you're thinking as the dev. So this is where you get in that DevOps space. Ops is going to be informing dev, hey, these are the things or tools that I need to have in place in order to make this image useful to me. Right? It becomes really challenging otherwise. There's options, right? Like I could be running in the image and then just pull things in on the fly there. It's just convenient just to have the things you know that are your default go-to tools involved on your image already. And they might vary based on the tooling that you're using. You might want JPS. I might want, lost my train of thought, but you might have tools specific to the environment you're in. The build. Again, kind of the early days of Docker builds is like build it inside the Docker. In other words, just like the Docker file will include the process of building. It's the recipe for building an image. And that can be terrible, like in size. Like there's no advantage to that. It's just a convenience to developers, I suspect. I'm not sure the drivers other than that. So what you're looking for, one, build it outside the image, the Docker, and copy the executable or the end result of what you need into the image. You don't need all the build artifacts or all the tools that are necessary, like build essentials. You don't need all that in order to run the service that you're looking to run. It's built outside, copied in to create the image. Or build it inside the Docker that will then build the Docker. There's a number of ways you can approach this, but there's no reason to be building inside the actual image that you're going to be deploying into production. It just causes bloat for no reason or no value. Okay. Oh, this is where I had to build out. Okay, so some maturity model of the image itself. First, hand-coded, handcrafted. I got it running. I'm super excited. We moved to Dockerfiles, which means I have repeatable builds. I can build the same thing regardless of the platform and the machine I'm on. It doesn't just work on my machine. All right, the next level of maturity you tend to get to is log maturity. You've got a couple of options here, really. One is kind of the Docker way. Standard out goes to standard out. Errors go to standard error. And we'll use Docker tools to manage it. All right. Another approach, potentially landing in, and it's actually might go in concert with this, but landing in like FileBeat or some way of getting it to the elk stack. Essentially a way of managing logs that you have driven into your architecture. But this is the next level of being able to get to it. In other words, if I'm landing this inside of my Docker container, a couple of issues come up. One is I fill up the disk of the Docker image that I'm in when I'm at runtime. Eventually, I guess with proper log rotation that might go away. But the other part is it makes it really, really hard on ops. It makes it super hard to understand and debug things. The next level, we're working with environments. So we go out to persistent volumes and secrets and ports, and we've expressed ourselves in a way that we want this Docker image to be landed and run inside a production environment. Yeah, we could talk through that if you have questions. We're always looking for immutable, and then we go for lean, trying to reduce the size and latency of starting up. When you get into any of these clustering technologies, there's some leeway in them, but oftentimes they're tuned with certain timeouts. What you're not looking to do is have an image so large that you reach a timeout in the process of trying to land it on a node. Or you're trying to spin up a pod and it just can't because you have fetching issues. It's pretty rare, but I have worked with plenty of clients where we have sizes of images or timeouts so low that that's a problem. And then the next level of maturity is orchestration. I brought it up before. We're going to talk about it in a little bit more detail in just a few minutes. Okay, registry management. I talked through most of this already, actually. The fact that we have a SHA for each tarball. We're landing those tarballs. It is possible to have two images that have basically the same base with small changes. That tarball that comes down for that small base, that small change is super small. So it's a really great way of managing these details. All right. Command versus entry point. There's a couple things that you need to manage here that usually are outside dev space. As devs, we just want to make something run. As you start to operationalize this thing, there's a couple of additional needs you have. And one of them is you might be versioning the command outside of Docker. I have this descriptor, YAML or JSON, that's going to describe this Docker image almost like as an artifact or a dependency, and it will run a certain command. There's huge value in that. Oftentimes, there's things that you know as an ops person that you want the ops person to be able to leverage that you don't know in dev. In addition to that, you might decide as a developer to add in this friendly little wait for it type thing. So if you're spinning up a front-end thing, you're waiting for a back-end thing, and you want to decouple the dependencies of Redis has to be up first before I can do this. We can actually spin up the front end. It will wait for Redis, and when it finds it, it will then be running. Right? This is the kind of maturity we begin to see as we operationalize it. And the question becomes, do you do that in the dev space and have the same image and the same command in all spaces, or do we leave that to the versioning of whatever artifacts you're using to launch the Docker container in production? All right. Docker. All right, let's talk about orchestration a little bit more. As we start to go into the orchestration space, there are actually two reasonable differences. Well, there's lots of differences, but there are two runtime differences that I want to discuss. If you're going down the Kubernetes space, essentially the underlying runtime engine is containerd. If you're running in the Mesos space, we can run Docker, which essentially is containerd, or we can run UCR. There are some pretty significant differences about those approaches at the advanced end. With containerd as a simple example, if I'm inside of a pod, I have multiple containers. If one of those containers exit out, say an exit 0, the container is considered to be failed, and it will be rescheduled, depending on what its policies are. In the UCR space, it is possible to have multiple containers inside of a pod. We really refer to it at the Mesos level called a task group. I can have a process that is spun up or spun down, in other words, exit 0, that is not considered a failure as an exit 0. Everything stays up and running. So you have some different flexibilities, but also some different characteristics of how things are managed. So you want to just be aware of those details. And just completely how you manage an ops space for Kubernetes is really strongly different in how you annotate things versus the Mesos space. I can go into a lot of that detail later on and just kind of some huddle afterward if you want. At the end of the day, though, because I like the comfort of knowing this, I guess. At the end of the day, whether it's old school Rocket, AppC stuff, or let me containerize that for you, that's pretty old school, or containerd, or Mesos, at the end of the day, it's namespaces and C groups. That's it. Like if you were gonna, you really want to understand what's going on at the lowest level, just dig into control namespaces and C groups, which may beg the question, if this is relatively new to you, is there a consequence, a negative consequence of running a container? Am I paying a penalty? And the facts are today in the Linux world that namespaces and C groups are enforced on all things running in Linux all the time. As root, you're in the root namespace and C group. You are always running in a container on Linux. There's no negative consequence, which is why we talk about the value of near native speeds, especially startup times and such, right? So that to me is, if it's new to you, seems to me to be super valuable, useful information to understand. There are some nuances in how those containers or namespaces and C groups are managed, and I went through some of those, delta between containerd and the UCR. But as a whole, like how things are constrained, it's still C groups. How they view things is namespaces. All right. Now, expecting that this might be somewhat new to a lot of you, oh, you know what? I have slides, and then I might go through them, and we'll see. So I just took DCOS. It doesn't matter which one you're looking at. In this stack, we have something that's going to control. The only difference between a Kubernetes space, so to speak, and the DCOS space is that I can have, it's a two-level scheduler world in the Mesos space, which means really something really simple. I have low-level abstractions in the Mesos tier that is not intelligent. It knows when things fail, and it knows to report those failures to something that is intelligent. In other words, a controller that knows what to do. We call it a scheduler or a framework. In this case, I'm using Marathon. Marathon's job, just to keep things running. That's the whole point, long runs, just forever running, right? In the Kubernetes space, we don't have multiple controllers, so to speak. We have one scheduler. It's always one scheduler. 2016, a couple years ago, we introduced kind of a new concept. CoreOS brought it up, something called operators. To a certain extent, they're like frameworks in the Mesos world. So it's interesting to see that the Kubernetes space is moving kind of in the Mesos direction, at least in this space. There's one really strong difference, though. As an operator, you understand how things should be managed and handled based on failure, and you basically communicate that to the one scheduler. The one strong difference is that in the Kubernetes world, there is only ever one scheduler. That's the real strong difference. But we're going to see more and more operators. In fact, this shirt I'm wearing, I'm on an open source project that's really new called Kudo, which is intended to be a way of abstracting operators in a way where you can describe the operations more in a declarative way instead of needing to write a ton of code. We have found that lots of organizations trying to write new operators write tens of thousands of lines of code, and we think that's overkill. We can abstract a lot of that away. All right. Again, another topic we can go into strong detail on if you'd like to a little bit later on. In this space, all I'm saying, all I'm trying to communicate on the slide is I post to Marathon or to a scheduler, I want this to run. This becomes the hard part in ops, right? Where does it go? You don't know. Unless you've articulated that, unless you've selected it on a label, it could go anywhere. And that becomes a very scary moment. But guess what? That makes it great. All the number of nodes I have is cattle. They're just all as effective as anything else. I don't really care where it lands until I do, right? This gets further down the path of ops, but at some point you're like, well, wait a minute. I do kind of want to orchestrate these things across fault domains. I'm going to have 3 instances of this, and I don't want them all on the same rack. I don't want them on the same AZ. I need to be able to communicate how I want these things to be orchestrated, and that increases the bar, right? That increases my needs to understand how to manage these things. But the simplest level, like the demo level, the level we're at right now, is I say, I would like an instance of Nginx running, and it could land anywhere, right? Assuming it meets the constraints, and the default constraints, the minimum things I need to express, how many cores do you want to run on, how much memory do you need? And what your max is really. That's the core of it. Oh, I have a node over here that matches that. Okay, we're going to land you there. That's it. Another pretty strong difference between the Mesos world and the Kubernetes world. In the Kubernetes world, the scheduler has kind of a view in the entire cluster. You can see it all, which has some advantages, right? But in the Mesos world, the scheduler doesn't see everything. All it gets is offers. It's like, hey, I've got more resources. Do you want to use them? It's federated to a certain extent. And I'd be careful at deciding one is strongly better than the other. They both have advantages and disadvantages. There is not today a cluster of Kubernetes that can reach the size of the clusters we have on Mesos, period, by a long shot, right? And there's some strong challenges with running containerd, or Kubernetes, we could say, with more than 100 instances per node. And I do scale tests roughly every month where we'll spin up 300 or so on UCR. So there's these balances of things. You just really have to dig into the heavy details in order to understand them. I might have gone off the rails. The idea here is that I say, hey, I want to spin up an instance of something that just lands out there. And now I say, I want more than one. And it just lands out there somewhere. Now you can look, it's almost obvious, I hope, but now we run into a whole new thing. How do I discover things? Like that's the first challenge you run into is I used to have, in fact, it's almost comical. I have well-known ports usually, and I have an A record, a name gives me an IP address where I can go find this thing. And now, what do? Now it could land on any IP. Potentially the pod could have its own IP. Ports? What is that? The part that's funny to me is that we had standards that have been around for ages, in internet terms, ages, for DNS. And one of the standards, like we all know A record because we use it all day long. We're very familiar with it. But there's another standard within DNS called SRV records, which identify ports. So you can query and say, hey, the thing at this A record, what port does it use? How do I connect to it? There's plenty of applications that don't even implement that. So it's not known to developers at all. So we end up doing crafty little things by having front-end load balancers or mid-tier, mid-range load balancers to manage these kind of details. And then we create what in the Marathon world we call service ports, ports that are backing essentially a large number of other applications on who knows what port, right? All right. This would be the layout, a JSON for managing that. What's great in the Mesos world is I don't have to be in a container in this example. Getting closer to our topic, here's an example of using Docker where we specify that I want to run Cassandra, and it's going to be 206. All right, so we can, simple stuff. All right, we can change instances on the fly. You're like, hey, do I always have to look at this command, JSON stuff? You remember the old days when we had like way too many angle brackets and we're looking at SOAP packets and we hated life? We're like, we're gonna make life better. We're gonna make it great again. Well, now you get to look at a bunch of YAML. Right? The whole world will be YAML. And that is your fate, unfortunately, in this space. There's not an easy way to soften that. All right. You know what, I'm going to exit here. I don't know what I'm going to show yet. We'll see. I spun up a cluster before I started the presentation. We have a tool internally that I tend to use for spinning up a cluster. This is on Amazon. I pushed it out to Frankfurt Datacenter so that it would be in relatively close proximity. This is always the danger for doing a presentation is typing. And we can do roughly the same thing if we wanted to switch into the Kubernetes space. I really don't have a preference anymore. I used to, but I don't anymore. Now I don't care. The orchestration is orchestration. In the Kubernetes space, you would see a dashboard. Here we've got something, I don't know if we call it a dashboard. This is roughly the same thing. It gives you a view of the cluster. I've got nothing running, right? I have a bunch of services I could run. If I wanted to, I could go in here and I could say, I want to run this thing. We'll just call it Nginx. We'll get a container, Nginx. We don't have any real constraints other than that. I'm just going to run it. So I have one instance. I have one instance of this thing that's just popped out there somewhere. Don't know where it's going. It landed. That's awesome, right? Well, it's currently deploying, I should say. I didn't put any health checks or anything like that on it or readiness checks, so it's just, the feedback is just either it's deploying or it's running. That's the only options at this point. I could also go out here and say, hey, do we have any tasks running? Oh, yeah, I have this task running. I could go in here. You know, it's been a while since I've done this, actually, but let's see here, log. See how good I am. There are no logs for that container. Isn't this awesome? This is the first challenge that we tend to get into is once I spin this up in some random place, how do I get to it? And in the early days of orchestration, literally, people would go, well, I can see with the tooling I have that I have, 5 or 6 nodes? And I can see that it must be on this node because, well, it's the only thing running, and I can see a blip there, right? Now, that's going to be a problem long term, right? Or I could go over here to the services, click on the service itself, and see that it's running, and find out which agent it's on. I literally would SSH into that agent. I would then start to mess around and try to understand what's going on in that particular node on that particular process. But we don't really need to do any of that, whether we're using DCOS or Kubernetes. You should be able to go in and get the output of the logs. I could go out there and say, hey, I want standard error instead. I could go out there and, oh, guess what? This is cool, right? I could say, back up. We could say we want to scale this baby. We want 3 instances of it. They're spinning out there somewhere, I hope. Yeah, there we go. And guess what? There are 3. It was hard to see, right? Like there's a breakup of each one. This is the start of one here. Here's the start of another one. I could specify the exact thing or get all of them at once. I could also do something crazy, right? I could say follow. And now I'm following all 3, all at the same time, right? So the tooling has improved to help manage the cattle or the instances of Docker running inside this space. All right. Click. Thank you. Okay. I'm going to leave some time open for conversations. I actually love feedback, and it will drive the direction of conversation. I can go on any of the things that we brought up. I could talk at length about them, and I can go pretty deep. So I'm going to do that in just 1 second. The things we didn't talk about as we start to move in the ops space. Let me advertise first that maybe checking out Cloud Native and seeing what tools are there would be a good way of understanding what ops needs, because many of the things that are in the incubator or graduate projects today are things that we truly need, and they're kind of listed up here. The next level of maturity that you have is I need metrics. I need some way of observing this thing. And we have found that metrics tools that were great for a statically partitioned world are just not great for a dynamic world like what we just looked at. The solution to that, again, debatable, I'm not selling anything, but it is open source, is probably Prometheus. Prometheus is a great product. Usually we use Grafana on top of it to give us a visualization and provide some alerts as to what's going in. As soon as you start to evolve your thinking, adding in metrics into your own services becomes a huge advantage or value. Right? We're not looking for metrics just at the infrastructure level. We're looking at metrics through the entire stack. But that requires developers actually adding metrics into their applications and then exporting them or making them available to the system. Push them, if you will. Other ones that might be useful, tracing. I need to be able to trace, so Jaeger or, I think I'm losing my train of thought. You'll find them out there. But the OpenTrace API is probably where you want to go. We didn't talk at all about health checks and readiness checks. You need to know that this thing is ready to serve or is no longer healthy, or how I want to react to those things. That's, again, what the ops team is going to need to have some exposure to. It might mean, as part of your application inside the Docker, as you start to create an app in your microservice-based architecture, that you provide an endpoint that defines health. Oftentimes what happens is very immature. We're like, yeah, that process is running. Yeah, we know that it's running, right? What you need is the service that is being provided by your creation, is it doing the right thing? Are all of the things, expectations that it have met so that it can honor whatever is expected from its API? And then it often means creating a health endpoint to be able to do that, to ensure that, if you will. And then we didn't talk at all much about recovery. All right. I'm going to open it up. It says 2 minutes and 50 seconds. So I probably only get one or two. There's what? Oh, yeah, you could. All right, yeah, good point. Somebody informed me of that 30 minutes ago, and that was 30 minutes ago. All right. Is there any special solution for load balancing Dockers? No. Yeah. The industry is pretty much standardized on using HA proxy. That's been in its history. It's been there forever. We use it quite often. HA proxy is great for being that load balancer. We have Marathon LB or Edge LB within the DCOS space. Essentially, that's HA proxy with some special configurations. That said, I could also say yes. In the up-and-coming space, we have Istio, Envoy, and Linkerd that are going to provide solutions that provide an element of load balancing depending on what you're talking about. So that question is actually kind of loaded. Are we talking about the front end, like ELB, the front end load balancer into the whole ecosystem? Very common to have a load balancer that is the front to a number of services. Frankly, we could consider Kubernetes proxy as somewhat of a load balancer on the node that it's on. So you're going to see load balancers up and down the stack for providing a variety of services. Is there one? No. Is there many? Yeah, there's plenty to choose from. Again, with advantages and disadvantages. The challenges you have, right, in this space, just to be clear, is you might want to optimize for local, but at a higher end, that doesn't make any sense. And you might have timeouts that make sense at the ELB, which makes sense for an end user. But in the mid-range, those timeouts make zero sense. You have service level agreements that must be maintained that kind of force you to do different things and respond in different ways. Do we have any tool recommends scanning images? No, I don't. I hear those are coming, and I hear Docker is kind of pushing to provide security options. I know less about that. That is an opportunity. I do get what you're saying. I will say this, that plenty of my most secure, like government agencies secure, organizations using Docker, they never use a Docker image out of the hub. They build all of theirs. So that's a certain level of maturity that it depends on your size of your organization, whether you're able or willing to to do that. So sorry I don't have the exact answer on that. Is it possible to profile Java? So Java becomes, this will probably be my last question, and I'll get out and answer more and leave this open for the next speaker. But Java is somewhat interesting and problematic. Hopefully, if you've been in the Java space and container space, there's been an evolution. Java 9 introduced the ability for Java to recognize like C group constraints for memory and use that as its max, which is awesome. A couple of other advantages that have come through 9, 10, and 11. One of the problems that you have is a lot of our tooling within the Java space provide different mechanisms for connecting into the JVM. One of them is to look at like the tempter and look for the special files that land in that tempter to be able to load that information into that environment. And unfortunately, in the container space, that is almost always private, which means I can't see it unless I'm on the node inside the container. So there are still challenges in the Java ecosystem for certain tooling. Obviously, you could open up RMI and use like the 1099 port and try to leverage some of those details if you wish. But yeah, there's not a perfect solution in that space for sure. I was talking to Charlie Hunt a year or two ago, and that is top of mind for them. Like this is the thing they want to try to solve, is to help. If you have a specific need or interest, let me know or let Charlie know, and we'll make sure that we're pushing that. I think they just need customer feedback to set the priority, if that makes sense. All right, I'm already over by 1 minute or so. I do want to answer these. Dziękuję. And